This is our last installment of the Froggy and Doggy show for this year. So here we have featured Frog. Frog, who is a sane and reasonable frog. In other words, he's rational. And here is Dog, who is also quite lucid and rational. So what we hear is Frog times Dog are rationals. We're multiplying rational frog and rational dog. Multiplying rationals. Okay. So we're going to talk about multiplying and dividing rationals. So if you would, in your cipher, if you've got it, or just write it down, because writing it down helps you to learn it. Write down these provisions about multiplying and dividing rationals. Pause it and write it down. Okay, once you've written it down, you'll see that it's pretty much just like the fractions that you learned how to multiply in 5th or 6th grade. Everything has to be a fraction, so if it's not written as a fraction, put a 1 under it. The difference here is we're going to factor it fully so that we can cancel, which I'll talk about more. And then back the way that you've learned to multiply fractions, we'll just multiply the top times the top and put it on the top, the bottom times the bottom and put it on the bottom. Division will be exactly the same thing, except we're not going to divide, because dividing is like way too much trouble. So instead of dividing, we're going to do multiplying, which is easy. To change a multiplying to divide, you're familiar. We multiply by the inverse of the fraction. In other words, we flip the back frac and multiply the back fraction. Let's talk a minute about how this stuff works, and then we'll get into the more complicated. Okay, a reminder, a simplified fraction is one that is both reduced and proper. That's particularly how you did it in middle school. In middle school, you pretty much didn't leave an improper, but in high school, that's not necessarily the case. Okay, let's look what it says here. Reduced means it has no common factors. These do not. Proper means the numerator is less than the denominator, which this one won't turn out to be. This one is not proper. 16 over 5 is improper. 2 over 3 is proper because its numerator is less than the value of its denominator. Here the value of the first numerator, 16, is greater than the denominator. So this one is not proper. It is reduced because it has no common factors. They are both reduced. 16 over 5 is improper. 2 over 3 is proper. Okay, what do we do to multiply? Y'all know this. 6 times 2 to top, it times the top, it goes on the top. To bottom times to bottom goes on the bottom. And there we have our answer. Okay, this happens to be reduced because it has no common factors. This one is reduced. It is not, however, proper because the numerator is larger than the denominator. Were you to want to make it proper, if you were asked to, it'd be how many 15s are in 32, which is 2, and there were 2 left over. So that would be proper as a mixed number. In high school, we rarely ask for you to make it proper, but if you're asked, you should make it proper. Now, a few things about doing this. I'm going to talk about canceling. Okay, and I have Foleys there because Foleys used to be the Houston department store. That was the place in town to shop for decades, probably longer than that. But anyway, and the reason I'm going to talk about Foleys just a little bit is because, first off, I like Foleys. It no longer exists, but I really liked it. But it had something in common with it. Foleys would have a red apple sale, and it would always be on a Wednesday. And they called it a red apple sale. I don't know why, but they did. And it was a sale where they'd make really good sale. They'd mark things down, and it was always on a Wednesday. Now, this was back in the days when dirt was young, and so was I. There was no such thing as a scanner or electronic pricing. Every item had a tag on it, a price tag that said how much it was. So when there was a sale, the clerk had to physically go around all of their area of the store and mark out what the price is. So if we had a price that this item was $5, the clerk would have to come and physically, usually actually with a pen, mark it out and put that it's on sale for $4. They have to do that to every item. Now that's a lot of trouble, and it takes a while to do that. So what that means is, when there was going to be a red apple sale the next Wednesday, the next day, on Tuesday night they had to stand around and mark off stuff because it takes a long time to do it. And if you were in the know, you knew that if you came to the Foleys on Tuesday night, not too long from closing, that everything was already marked down and they'd give you the sale price. So you would get the sale price without doing it. So the price was reduced from the regular price to the sale price. And on Tuesday night before the sale of Wednesday, it was pre-reduced. And life was a lot better when it's pre-reduced. Multiplying is a lot better when you pre-reduce. Now, we don't call it pre-reduce. When we're multiplying, we call it canceling. How do we do that? Okay, remember, you're going to have to multiply the top times the top, put it on the top, bottom times the bottom, put it on the bottom, and you're going to have to get rid of any common factors. So how would you normally do this without canceling? You would say 6 times 15 is 90. Over 4 times 5 is 20. Then you divide both of them by 10. Oh, there we go. And you get 9 over 2. That would be your final answer unless you needed for it to be proper, in which case it would be 4.5. Okay, pre-reducing, in other words, canceling, is you take out the common factors first. Here, what did you do? You took out a common factor of 10, divided by 10, you divided by 10. You can do that first instead of last. So what would that look like? You take any number that's in the numerator and match it with any number that's in the denominator. If they have a common factor, you can divide it out. I see that 15 and 5 both have a common factor of 5. So I can divide by 5 for both of them. What am I doing here? I'm essentially saying I'm doing 5 times 5. What's 5? I mean, I'm dividing by 5 and dividing by 5, which is the same thing as 1, right? So it's the same deal. We're not changing the value. We're just taking out the common factors. So 15 divided by 5 is 3. 5 divided by 5 is 1. Then I notice that 4 and 6 have a common factor of 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Once I've done that, I multiply what's left. Top times the top goes on the top. 3 times 3 leftovers is 9 for the top. 2 times 1 leftover is 2 for the bottom. Okay, look at this. We did the same thing here. Here we divided them both by 10. Here we divided them both by 5, and we divided them by 2, which is the same as dividing by 10. Now, on this particular example, it's a small one, and it's really not a big deal. And so it's not going to be that big deal whichever way you do it. But in algebra and in higher math, it's sometimes going to be a really big deal as to cancel first or to not, or to multiply first. So here, let's try one here that's a little more complicated and see how it works. Okay, again, review of canceling. It's okay to cancel any numerator with any denominator wherever located. It's okay to cancel more than once. So let's see how that works. Okay, there's a 5 and there's a 15. They'll both divide by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. Okay, well, I have a 27. You can do this in any order, it doesn't matter. I have a 27, and that's a bunch of 3s. 3 times 3 times 3. Oh, I see a 3 over there. I'm going to do that. 27 divided by 3 is 9. 3 divided by 3 is 1. Okay, well, let's see. Oh, look, 7 and 14. Those will both divide by 7. What else? 7 and 21 will both divide by 7. 1 and 3 when I divide. Oh, look, there's a 3 and there's a 3. But I've already canceled that one. So what? I can cancel it again. They'll both divide by 3 and we'll get 1. Any more common factors? Let's see. see, there's a 3 and 18. 18 is 6 times 3. So I can divide by 3. What else? Oh, look, 6 and 9 both divide by 3, so I can do it again. 6 divided by 3 is 2. 9 divided by 3 is 3. What else? Okay, look, 8 and 16. 8 divided by 8 is 1. 16 divided by 8 is 2. Okay, is there anything else I can do? Oh, look, there's a 2, and there's a 2. I'm just going to do it again. I could do that one over there. It doesn't matter which one I do. Okay, now what's left? A bunch of 1s and a 2 are in the numerator. A bunch of 1s and a 3 are in the denominator. Okay, well, 2 and 3 don't have common factors, so I'm done. So now this makes a really, really hard problem. Y'all listen real careful here. See if you can figure this one out. I'm going to multiply all what's left of the numerator. So it's going to be 1 times 1 times 1 times 1 times 2 times 1. Ooh, that's tough. 2. To do the same thing in the denominator. Again, just regular fraction multiplication. All the bottoms go to the bottom. 3 times 1 times 1 times 1 times 1 times 1 is 3. She shoots, she scores. Now, that's a whole lot easier than multiplying first and then reducing. You're going to pre-reduce like going to Foleys on a Tuesday night. Another thing about Foleys. Now, if y'all were in class, you'd have to put up with my stories. And so you might as well have a story to put up with now about Foleys. I looked around and I found my Foleys credit card. It used to be there wasn't things like, Visa, and there were no debit cards, and there were none of that. An individual store would let you buy things on credit at their store. And they were very picky about who they would give it to. This particular card, I think it was this one, but it might have been an early one. But anyway, this particular account, when I was at Rice University, I was not an adult because when I was there, you had to be 21 to be an adult, and you have to be an adult to make a contract to have credit. And so no one, absolutely no one, would give you a credit card because you can't enforce it against a child. Because I was 18, 19, 20, I wasn't 21. So I was still legally a child, and they would give nobody a credit card. So, but Foleys gave credit cards. They put an ad in the Rice Thresher, which is the newspaper for Rice University, saying that they would give credit to any Rice student. So I asked my mother. My mother said, yeah, you can do that, but you have to be careful. You have to be careful with credit. And so I did it, and they gave me some really ridiculous amount that I could spend, like, $100 or something like that. Now, when I was in college, $100 was worth a whole lot more than it is now, but it still wasn't very much. Because they figured that once people were college graduates, particularly from Rice, they didn't do it for the other schools in town, that they would be good customers. And they figured right with regard to me. So they gave me a credit card that I couldn't waste them much money on. I couldn't lose them much money. And my mother told me, Gail, when you get this card, you take the bus down, if I didn't have a car, you take the bus downtown, and you buy something little, like something you need, like hose or something. We all wear hose, and nobody wears hose anymore. And they would mess up, and so you'd have to buy them. Take the bus down and buy something that doesn't cost very much, but that's something that you need, and never buy more than you can pay for, because you're building credit. So I'd go buy some little item, or a nice plate, or I remember I bought some cups for my dorm room, different things, but I always had the money to pay it. And she said, when the bill comes, you pay the bill. You pay it early. You never pay it late, and you pay it in full. Even if they let you pay part of it and pay part of it later, you don't do that. You only buy things that you have enough money to pay for, and then you pay it in full when it comes on time. I said, yes, ma'am. And I did what she said all the way through Rice University. And then when I graduated from Rice University, I needed a bed because I wasn't in the dorm anymore. And so my daddy said, go down to Foleys, they'll make you a deal. They'll give you some kind of arrangement, like you can pay a little bit down and they'll let you take the bed and you'll have to pay so much every month. And I said, okay. So I did what my daddy said. I went down to Foleys with my credit card that I'd been paying on time every month and said, and picked out a bed. And then the salesman, clearly this 22-year-old young person who had no credit except with him, looked at him and said, I told him I'd like the bed, and he went back to talk to the credit department to see if I was a good credit risk. Did I pay my bills on time? Because whether I paid my bills on time meant how much I had to give them to take the bed. It's called a down payment. You pay some, and then you pay a little bit along until you pay it out. And he came back from the credit department, and he was astonished. You could tell he was like shocked, because he said, the credit people say you don't have to give us anything. He said, you can just take the bed, we'll deliver it to you, and you'll pay us. The credit department, you are good to your word, you pay your debts, and we trust you. And so they gave me this big fancy, well, it wasn't fancy, but it was expensive to me, bed, and I didn't have to pay him a cent. And of course, I paid it off and was a loyal Foleys customer from then on. There's no more Foleys. Macy's bought it. Things like that happen. And Macy's isn't the same as Foleys, but I liked Foleys. And my mama's advice to me, I now give to you. Don't get yourself in trouble with credit. Yes, they will let you dig yourself in a deep hole that you can never get out of. Live your life so that in a way that you can afford, and you'll be better off. That's my advice for today. See, this is a credit card. This is a really old one. You can tell it's a really old one. See, there is no magnetic strip. You know why there's no magnetic strip? Because there were no magnetic strips, just like there weren't beepers to get your prices or anything. That thing didn't exist then. That's old. Okay, back to canceling and pre-reducing, like at Foleys. You think that last one was a mess? Here, pause the video and try to do this one. Copy it down and cancel everything that you can find to cancel. Don't start it back up until you've got it all canceled. Okay, pause it. Here's how I did it. Remember that you can cancel any numerator with any denominator as many times as you want. Now, some of y'all are still probably skeptical, saying, I don't want to do this silly canceling. Okay, well, you can multiply all these and then divide, and that's what you're going to get. And remember, you do need to learn to do these on your own without a calculator. As I mentioned in class, we're past the days when you're going to always have a calculator. Schools and businesses want to know if you know what you're doing, if you understand it. And when you take these tests, there are going to be significant portions of the test in which you are not allowed to have a calculator, which means you have to do it yourself. Canceling, or if it's Foleys on a Tuesday night, pre-reducing, but that's not the name for this. Canceling will get you there much more quickly. It'll help you to see the mathematical relationships, and it'll get you to where you need to be a lot faster. So this is just 3. All of that is just 3. Okay. Now let's put some variables in it. You should have already had pretty much all of that, but let's make sure that you can do it with variables. So let's start with this one. Okay. We have a rational times a rational, a fraction times a fraction. And remember, we can cancel anything that's a numerator with anything that's a denominator if it has a common factor. Well, I see right there, 9 and 6. 9 and 6 will both divide by 3. What else? P. There's 2 P's on the top, 4 P's on the bottom. If you go into brain freeze, just write it out the long way instead of using the shortcut. 2 P's on the top, 4 P's on the bottom is the same as P squared on the bottom. 5 and 7, can't do nothing with that. So what's left? 3 times 5 is left in the numerator, that's 15. 7 times 2P squared is what's left in the denominator, and that is 14P squared, which is the answer to this one. Okay? All right, here you try one. Pause the video and do this one. Here's the answer, the way I've worked it. Again, you want to cancel everything that you can cancel. Not just to make it easier at this point, but it's going to make it much different in higher math. You're going to have to learn to be able to do this. So what's left, I've canceled the x's, the 4 and the 8, and I see what's left. 5 times 1 times 1 is 5. 2 times x times 3 is what's left for the denominator. Okay. Now, one step more complicated. Let's look at this one. Okay, it's getting a little bit messier here. Let's go back to what we started with, not the frog and the dog, but this. What are we going to do? To multiply and divide rationals, everything needs to be a fraction. We're going to factor fully before we cancel, and then we'll multiply normally for fractions. Okay, factor. But Miss, I thought I'd already done with factoring. No, you're never done with factoring. Okay. Actually, I just had a private school contact me about one student who didn't learn to factor very well, and they're going to make them take algebra again. If you hadn't learned to factor, now's the time to do it. Okay, let's look here. What are we going to do? Just say, I can factor. So a times c is negative 12. B is 1. So what we'll multiply to get negative 12 and add to get 1. Okay, that's going to be 4 and negative 3. So we'll go ahead and go through the factoring by grouping here. And remember that my 4 and negative 3, that's how I got my 1. 4 plus a negative 3 is 1. That's this 1. And I'm going to substitute my 1x with 4x minus 3x. 4x minus 3x is 1x. And I'll copy the stuff around it. Then make my groups. What do those have in common? X. What's left? X plus 4. What does the second grouping have in common? Negative 3, which leaves x plus 4. Then I factor out again. Divide out the 3 and the 5. Between the x, x minus 3 times x plus 4. Okay, that's my numerator. X minus 3 times x plus 4. And my denominator, I can just look at that and tell they both have a 5. So I'm going to factor out the 5, and what will be left is x plus 2. Okay, negative x minus 2. I really don't need to factor anything out of that, but I'm being sneaky. I see there's an x plus 2 over here in the denominator. And if there were an x plus 2 in the numerator, I could cancel it. I like to cancel, almost like on Foleys. So if I rewrite this as negative 1 times the quantity x plus 2, I have not changed the value because negative 1 times x is negative x. Negative 1 times 2 is negative 2. So it's the same value, but now I'm going to be able to cancel. So it's good to be sneaky. Here, I need to factor that. I can factor. AC is 4. B is 5. That's going to be 4 and 1. You're going to go through the same process, and what you're going to find out when you do it. Well, here, I'll just do it. Doesn't hurt to practice. 4 plus 1 is 5. 4x plus 1x is 5x. So that'll be 4x plus 1x is what I'm putting instead of 5x. I'll copy the rest of the stuff around it and group them. And what I'll have here is they both have an x. X plus 4. They both here, it's just a 1. I'm running out of space. That's a 4. Okay. Then we take and factor out again. That'll be x plus 1 times x plus 4. That now is my denominator that goes here. X plus 1 times x plus 4. Now once I've done that, I look at that and see if there's anything there that I can factor out. Is there? Well, yeah, there is. There's an x plus 4 and there's an x plus 4. A x plus 4 divided by x plus 4 is 1. X plus 4 divided by x plus 4 is 1. Oh, look, x plus 2. X plus 2 divided by x plus 2 is 1. X plus 2 divided by x plus 2 is 1. Anything else? Well, that's an x minus 3. That won't work. And that's a 1 and that's a 5. That won't work. That's all I can do. So now I look at what's left. Top times the top goes on the top. X minus 3 times the negative 1. Put it in the proper order. On the numerator, top times the top goes on the top. And then 5 times x plus 1 in the denominator. And depending upon who's asking for it, they might prefer that you write it this way. And just write it whatever form you're asked to do it. Okay? All right? You try one. Pause the video and give this a try. Here's the result, how I worked it. Okay. What are some of the salient facts here? In each case, I factored it as fully as possible. Here I notice that ubiquitous difference of squares. You see a perfect square, and a difference, a minus. It's always going to factor by the square roots, a plus and a minus. Square root of y squared is y. Square root of 4 is 2. A minus and a plus. It'll always work that way. Here I factored out the common factors. And now I put it down here, and I cancel. Y minus 2, y minus 2. Y plus 5 divided by y plus 5 is 1. Y plus 5 divided by y plus 5 is 1. And then 2 and 4, and the y themselves. When we do that, we see that the only thing left in the numerator is 1, 2, 1. 1 times 2 times 1 is 2. And the denominator, there's going to be a negative 1. You can either write it in the numerator or the denominator, not both. Or frequently, the best form is to put it out on its own, which is what I've done here. Then we look at what's left from the numerator. There was that negative 1. Everything else is canceled except y plus 2. So that's the final answer. Okay. Let's try another set here, please. Pause the video and work these. Here's how I did them. Again, you must factor fully everything that you can. In this case, we had an expression that was not written as a fraction, so we had to stick a 1 under it. Here I factored. I didn't do the I can factor, but that's the way to do it if you can't see it. Many of you can see it by now, and some of you can't. If you can't, then you need to do it. Again, we've canceled and put what was left. Top times the top goes on the top, bottom times the bottom goes on the bottom. Same deal here. This one was not written as a fraction. If you're multiplying fractions, everybody's got to be a fraction, so stick a 1 under the whole thing. And we'll go through the process here. Okay, now, dividing. Remember when you did fractions, dividing is just the same as multiplying, except you flip it first. Except you're not allowed to say flip it. You're supposed to say take the inverse, but I have a tendency to say flip it. So what do we do when we're going to divide fractions? Same deal. Everything has to be a fraction in fraction form. Then we're going to flip to back fraction. In other words, we're going to multiply by the inverse of the divisor. Flip to back frac. We'll factor it fully, cancel, and multiply across, which is exactly the same as multiply. And again, check for excluded values. We haven't been doing that today, but you will need to do that in the original equation, just like you did in the last unit. Okay? So, the only difference is you're going to flip to back frac. You're going to remember that you cannot ever cancel division. You can't cancel division, you can't cancel adding, you can't. Anyway, it's multiplication. So let's look at how this one works. Okay, it's just a division problem. it's a lot of trouble to divide, so we don't. We change it to a multiply, which is easier. Top times top on the top, bottom times bottom on the bottom. Why are you going to multiply? Do something that's hard when you can do something that's easy. So what we'll do is we'll multiply by the inverse of the divisor. In other words, we'll flip to back frac. That's to front frac, that's to back frac. We're going to flip to back frac, not to front frac. Okay, here we go. 16x squared. Copy the first one, the front frac, change it to multiply, and flip it. Or multiply by the reciprocal of the divisor. Now you can cancel. Here you cannot cancel. You cannot cancel division. Only multiplication. Now it's multiply, you can cancel. Okay? So let's do it. I see a 6 and a 12. They'll both divide by 4. And that's the only thing. That's all you can do. Because these x's are both. Okay. You can't cancel division. You can cancel multiplication. There's not much you can cancel here. The x's are both in the numerator. They won't cancel. So it's 4 times x squared times 5 times x, which is 20x cubed. And 3 times 3, which is 9. That's all you can do. So next up, give these a try. Okay. Pause it and work it. Remember that you cannot cancel division. So you cannot cancel until after you have changed to multiplication by the inverse of the divisor, until you flip the back frac. Once you flip the back phrase, it's Katie bar the door, you can cancel everything, which is what we've done here. The x's are in the numerator and the denominator, they'll cancel, some of them, and the same deal for the numbers, and then this is the final answer. Okay, one more. Give this a try. Remember, division is just too much trouble, so you're going to invert and multiply. And here is what we come out with this one. Again, notice that pesky difference of squares, it just shows up all over the place. A reminder, it's a perfect square, no difference. The difference of squares. So you should make sure that you can work these to get these results. And here endeth the lesson.